Hi, this is going to be the first of my videos on enthalpy changes, and in it I'm going to look at what is delta H and also then how we can draw enthalpy profile diagrams. So if we start with the very basics, if we have a reaction, we have our reactants at the beginning, and they react together, and they go to products. And so we've got energy in our reactants, and we've got then energy in our final products. And these aren't necessarily going to be the same. So if there's more energy in our reactants than there are in our products, then that energy has to go somewhere. And that generally comes out into its environment in heat energy. And so we get exothermic reactions when there's more energy here than there is here. And then also the opposite can happen. There might be less energy in the reactants and more energy in the products, in which case it's going to have to take energy from its environment. So that's where we get endothermic reactions. And we can link this to an enthalpy profile diagram. So on our enthalpy profile diagram, I'm just going to have up this side, I'm going to have an energy value. And then along the bottom, I'm going to have just the process of the reaction. So as I said, we could have a specific amount of energy for our reactants. So I'm just going to put that at this height. So they're my reactants, and they've got this amount of energy. Now with the products, have lower energy, so this is less energy, then we've got an exothermic reaction. And this difference between this two here, from here down to here, this amount of energy is known as the enthalpy change, or the amount of energy that's been lost in this case to the surroundings. And this shows an exothermic reaction. So this one will be exothermic. This amount of energy, this delta H, that has been given off into the surroundings. The opposite can happen. So if I go and draw a second one, and we look at process of the reaction, and energy, this time I'll put reactants here, put products with more energy. This time, the delta H, our products has got more energy, so energy's gone in, and that is signified by the delta H here, the amount of energy that's been taken from the surrounding environment and put into the reaction. And that is because these reactants here have lower energy. The products here have more energy. So energy must have come from somewhere to get this imbalance. In order to get any reaction to occur though, you've got to get the particles to meet the activation energy, or EA. I'll just make a note if I rub that top bit out and give a quick definition of activation energy, which abbreviate to E subscript A. This is the minimum amount of energy required for a reaction to take place. We can draw that onto our enthalpy profile diagrams as well. So here's our reactants, and if we got them together, put them into a bowl, a nice conical flask, a reaction might not occur. And that's because we don't have the minimum amount of energy required for the reaction to take place. So we might have to put energy in. So I'm going to show the process of the reaction just by a curve. So what this shows is me putting energy in, the reaction occurring, and then the products forming with lower energy. But I had to put energy in. And this, from here to the top of here, that is my activation energy. And so I had to put that energy in order to get a reaction to occur. And if we go the other way, the same thing happens. I go from the reactants here to the products here. We've still got our activation energy, the amount of energy we've got to put in order to get the reaction to occur. All of this occurs, or our reactions, when we come to our definitions in the next video. All of this occurs at standard conditions when we do our calculations, generally. Sometimes we have to do it at slightly different ones, but then that will get relayed to you. If in the question it just says under standard conditions, then we have two things as standard conditions. We have pressure. Standard is 100 kilopascals, or 100,000 pascals, and temperature is 298 Kelvin. So in the next few videos when we do calculations and it talks about standard conditions, these are our standard conditions. So that's our first little introduction into enthalpy changes.